Hello. In my series about ground-bound telescopes or observatories, I will today talk about the IRAM and the IRAM 30-meter telescope situated in France and in Spain. You will see where. And as always in these presentations, first I will show you a little bit of history and purpose, then the equipment, geography, some notable results, very randomly, just what I found in a quick search, and then a summary. As already mentioned, microwave is between infrared and radio and kind of has features of both. So many telescopes are working in the region bordering microwave bordering infrared, so around 1 millimeter wavelength. Everything below would count as infrared, and everything between 1 millimeter and 1 meter counts as microwaves. And then after 1 meter, definitely the radio waves start, as in this shown in this plot here. I've shown this already in earlier presentations. The first light of the interferometer on the Plateau de Bure was 1988. Unfortunately, 1999 there was a telecabin accident, which was also very devastating for the observatory because people working in the observatory crashed with this telecabin accident, because it's the main way to get there, and later a new means of transportation was built. 2014, the classical Plateau de Bure interferometer has been replaced by the new Northern Extended Millimeter Array NOEMA, and this was under construction until 2022 when the 12th antenna was inaugurated and all the antennas got new receivers. Otherwise is more or less an extension of the Plateau de Bure observatory. It is a collaboration between France, Germany and Spain. So the Centre National de la Recherche Scientifique from France, the Max Planck Gesellschaft from Germany, and the Instituto Geográfico Nacional of Spain. And they have collaborations with more research institutes in North America and China. Then the equipment, very nice view from the air, probably a drone picture. The antennas are on a Y shape, and for the new NOEMA observatory the rails have been extended so they can be moved up to 2000 meters. And as I already mentioned in earlier presentations, this helps to choose in the trade-off between resolution and field of view. So if you park the antenna further apart, the resolution is better, but the field of view is worse, and vice versa. And the same observatory also has a 30-meter dish that is standing in Sierra Nevada in Spain. And this is the place in France. It's relatively close to Grenoble. So it's 44 degrees north, which, as I mentioned earlier, may not be ideal for telescopes that need dry climate in a large part of the year. So probably parts of the year will not be very useful, whereas other parts of the year are. And here on the larger scale map, you can see that it's where the Alps start, more or less. So the air comes from here and will rise along the mountains, and then it gets a bit humid. That's inevitable in this place. But it's on the top of a mountain at 2,550 meters above sea level. The 30-meter telescope in Spain is in Pico Veleta in Sierra Nevada, which is relatively close to Granada. Here you can see the Mediterranean, and also here where it starts to go into the mountains, there's this 30-meter dish on 2,850 meters, so quite high up. I will show an image of this place later. Also, all of these antennae worked as part of the Event Horizon Telescope to image the black hole in the galaxy M87, which is this image, and later also to image the black hole in our own galaxies, which is a little smaller than the one in M87. And the image has been termed the shadow of the black hole, because of course the black hole itself cannot be seen, but the rim around it. And another type of observation is molecular clouds. So the telescope can just take out a spectral line and then image in this spectral line, which has been done here in the Orion B molecular cloud. And this can also be used for protoplanetary disks. And here on this plot, on this collection of images, there are different telescopes involved. So the one right bottom is from the VLA in the US, which is in the radio range. And the NOAA contributed the image at top right at 1.1 millimeters. So this is right outside the infrared in the very short microwave. As always, there is this trade-off: the shorter the wavelength, the better the resolution. But with an interferometer, the resolution is not proportional to the size of the dish, but proportional to the base length between the dishes, which can be up to 2,000 meters, as we have learned for the NOEMA. And these are molecules in a star-forming region, and they are plotted here. And this is phosphorus monoxide. This is important work because you can find out if the star that is born will be a second or third generation star. So to what degree does it have so-called metals in it? That's important for modeling, star modeling. So as a summary, I just plotted different areas where the two observatories, or especially the 12th dish on the Plateau de Bure, are working, and these I've taken from the yearly reports. So here there's the yearly report from 2013, and this is the yearly report from 2024. Unfortunately, the categories are not the same, so they can't be directly compared. But we can still say that lots has been put in the observation of star formation, for example. Quite a bit also in galaxies and active galactic nuclei, but a lot on star formation and star development. Here, this is the image I've promised to show, which is the 30 meters dish on the Pico Veleta. So thanks a lot for the attention, and Stay curious.